In this video, I try to give you a definition of deep learning and share with you some success stories. Machine learning is a subset of artificial intelligence. In artificial intelligence, there are many different paradigms, and machine learning is only one of them. And deep learning, this circle, is a subset of machine learning. So machine learning is not just deep learning. There are many other algorithms, and deep learning is only one of those algorithms in machine learning, but this is deep learning is basically a set of algorithms related to deep learning is the subject of this course. So this is how often deep learning is defined. Deep learning attempts to learn representation of data with multiple level of abstraction. We will understand this better later on in this course, but what do we mean by basically abstraction, level of abstraction? If say, I have a bird, right? So bird is an abstraction. In the real world, we don't have bird. We have different instances of bird, but we don't have the concept of bird. Concept of bird is an abstraction that we have created by observing many different objects in the world. We observed many different objects in the world and we created the abstract of book. Book doesn't exist. The concept of book doesn't exist in the world. This is something that we created. So this is an abstraction. This is an abstraction of flower. Okay. The concept itself doesn't exist in the world. So the idea is that deep learning learns some abstractions layer by layer, and in fact, it's different layers of computation. Basically it's a function of a function of a function. So if you look at the simple neural network, as we are going to see later on, feed-forward neural network, we have a layer. Over this layer we have another layer, and over that one we have another layer, and you can assume that in each of this layer we learn some abstraction of the data. So in convolutional neural network, for example, that we will learn later on in this course, in one layer we learn edges. That's an abstraction. And in another layer we learn, say, corners, and so on and so forth. We learn colors. And at the end we can recognize an object, but this object is composition of all of these abstractions. So it's this basically method of this type of models changed significantly many different tasks. So state of the art in many areas like speech recognition, classification, pattern recognition, and so on, are all models using deep learning. And deep learning or neural networks, deep neural networks, are inspired by brain. In brain we have synapses and connection between the synapses, and it's basically inspired by this. It's quite controversial that neural network is a model of brain or it's not, but anyway, originally it has been inspired by that. So if you look at the trend of machine learning and the trend of deep learning, you can see that it has been increased significantly over years. If you come back just 10, 15, 20 years ago, machine learning was quite luxury, very theoretical. We had very wise algorithms, but due to limitation that we have in computation, limitation that we had in data, we could have used those algorithms for 100 data points. And, we had an algorithm which could run in 1000 data points. We used to call it scalable algorithm X. So it's quite recent that machine learning can be applied to real world problems, and that's one of the reasons that it caught attention quite a lot. So let me share some of them with you. Is in speech recognition for 10 years, from 2000 up to 2010. You can see this is the basically word error rate of a speech recognition model, which was almost constant. All papers that have published and all models that have been built in this 10 years, uh, they improved a speech recognition model just incrementally, just a little bit. But in 2010, a deep learning model was able to decrease the error rate significantly. You can see it here, and that caught lots of attention. And in fact, now that we are basically talking to each other, the error rate of speech recognition models created by deep learning is less than human level. This is this dash line is human level error, and what we have now is less than uh, basically human level error. In image recognition, this is a huge data set. It's called ImageNet. And ImageNet consists of 1 million data points in 1,000 classes. In each class, we have 1,000 data points. And the images are quite realistic. It's not pre-processed images. And using, so the classification of this data, 1,000 different classes, is quite challenging. But again, using deep learning, these are the name of different models. Now the error is less than human performance zone. This is human performance zone. So human usually have between 5 and 10% error on this data set, and there are models of deep network which perform better than that. It got lots of news coverage when um, the Asian game of Go uh, was solved by deep learning, and basically deep learning was able to defeat um, champions of Go, and it defeats basically human professional for the first time.